Welcome back to part 4 of chemical equilibrium. This is Dr. Kofeld again. In this section, we're going to learn how to calculate Q, okay, and we're going to compare Q to K. And basically what Q is used for is to decide if the concentrations that you have at any one point are at equilibrium or not. So this is when you don't know it's at equilibrium. So if you have a mixture and it's not at equilibrium, you've got to you need to be able to figure out if it's still needing to proceed and go to the right, or if it's overshot and it's going to come back a little bit to the left in order to maintain equilibrium. And so what you do is you compare the measured current concentration ratios to the equilibrium constant, and if it is equal to that, then it is at equilibrium. So if Q is equal to K, then it's going to be at equilibrium. So you calculate it exactly the same way. All right, so exactly the same way, except you just don't know if they are at equilibrium or not. Okay, and so it tells you which way that reaction is going. So okay, so on the next slide, I tell you how to interpret this. All right, I already said if Q is equal to K, then it's at equilibrium, and the concentrations are not going to change between the products and the reactants. If Q is greater than K, that means that you have more products, okay, because it's a bigger number. You're going to have more products than reactants, and so if you have too many products, you're going to have to go back in the reverse direction, because you need to decrease the amount of products and increase the amount of reactants. If Q is less than K, that means that you have more reactants than you do products, and so you need to continue making those products until you get to your equilibrium. So if Q is greater than K, it needs to go back to the left, okay, back to the reactant side. If Q is less than K, it hasn't gotten to equilibrium yet, so it needs to proceed to the right, or proceed in the forward direction, or proceed to be product favored, right? Different ways of saying the same exact thing. All right. So in predicting the direction of a reaction by comparing Q to K, you know, and you can do this for Kp or Kc, either one, doesn't matter. Remember, because they're proportional. So if you've got all gases here, so it gives you the Kp. If you wanted to do it in molarity, you could do all those conversions, but why? It's the same proportion. So you have a Kp value. You've got a reaction mixture of I2, which is 0.114 atmospheres, Cl2, which is 0.102 atmospheres, and then the product, which is iodine chloride, which is 0.355 atmospheres. And it wants to know, is the reaction mixture at equilibrium or not? And if it's not, which way should it proceed? All right, and we have the knowledge to do this. So I'm going to set this up, okay, and I know that my Kp is equal to 81.9. So I'm going to calculate my QP, which is going to be products over reactants. You know, once you get this part, you can really work these pretty easily. But I'm going to look and see, okay, the product, I've got 2 of those, so that's going to be squared. So my products are going to be squared divided by my reactants times each other, right? So I have 2 of those. So that is ICI squared divided by I2 times Cl2. So that's going to be 0.355 squared divided by 0.114, and that's atmospheres, okay, times 0.102, and again, make sure that you are 1 with your calculator. All right, and so when you do that, your QP should come out to about 10.8. If you're off a decimal or whatever, it's okay. A tenth is okay for us. We're not going to the Space Center. All right, so QP is 10.8. KP is 81.9. So 10.8 is less than 81.9. So QP is less than KP. Now, what we say about the rules, if my QP is less, okay, that means that I haven't gotten to my equilibrium yet. So in order to get to equilibrium, I'm going to have to proceed to the right and make more products. So it is not at equilibrium at this point. Okay, it's not at equilibrium. It has a ways to go. I have to make more products, so I need to let that cook a while longer so I can make more products and get to equilibrium. So Q is the same as K, whether it's C or P, but it's at some time where the reaction is going where you don't know that it's at equilibrium. Okay, so if it's not at equilibrium, or you're in doubt of it, you're going to do Q just like you would do K, but then you compare it to K to see which direction you have to go in order to be at equilibrium. So there's plenty of practice ones on this one, and you should get in the habit of this. And the more of these KCs and KPs you do, the better. Okay, and that's all we're doing in this section, is comparing Q and K so that we can see what direction that reaction is going to go.